All right, we're going to have a fun little scenario here to discuss how to estimate areas under a curve. So let me read to you this scenario. I, Dr. Ricketts, was convinced that Harry, Hermione, Ron, and Neville were the sweetest wizards in the whole wide world. Little did I know that yesterday these little imps asked their first period teachers for passes to the bathroom, but instead snuck past the narcs, I mean safety and security specialists, to the faculty parking lot. They were pretty mad at Dr. Ricketts because of that impossible Unit 3 test. Harry brought a drill, Hermione brought her trusty Lego meter, purchased at Home Depot for $14.99, and Ron brought a diary. Neville acted as the lookout. Harry drilled a tiny little hole in the gas tank of my new Audi Q5. The four wizards watched gleefully as the gas drained out of the tank. Hermione, using her Lego meter, took readings of the rate at which the gas drained out every minute, while Ron recorded the data in his diary. Neville was so distracted by romantic thoughts about Luna Lovegood that she didn't even notice Mr. Click running out to Starbucks for a caramel macchiato, and she failed to sound the alarm. Mr. Click captured the four culprits and confiscated the diary, which he turned over to a very sad me. Being the true calculus geek that I am, I used the data that the wizards managed to record before being caught to make this calculus problem. So, what I have here is a table of values with time versus the rate at which the gas is being leaked out of the car. The first question says, what is the maximum amount of gas that could have leaked out in the first minute? Well, what we are going to do here is use the data in the table to estimate the amount of gas that leaked out. So the first minute goes from time equals 0 to time equals 1. And the rate at which the gasoline is leaking out is 3.5 at time equals 0, 3.5 gallons per minute, and only 3 at time equals 1. So let's pretend that the gas leaked out at this constant rate here of 3.5 over the entire first minute. Well, that means that 3.5 gallons could have possibly leaked out over the first minute. And I got the units by multiplying the rate times the time. So gallons per minute times minute results in gallons. The minimum amount that could have leaked out is actually 3, because this would be if it started here at 3.5, like let's see, this is 3.5 gallons per minute, and then immediately dropped right to 3 and stayed at 3 for the full minute. So the minimum amount that could have leaked out is exactly 3 gallons of gas. So that means that the amount of gas that actually leaked out would be between 3 and 3.5 gallons. And if you notice, I'm using units for all of these. These are real-world problems, so you have to put in units. If you had used either the max of 3.5 gallons or the min as 3 gallons, what is the most you could be wrong by? Well, if you chose 3.5 and the answer was 3, you could be wrong by half a gallon. Same as if you chose 3 and the answer was really 3.5. So the maximum error is 0.5 gallons. So if we wanted to reduce our error, what might be a reasonable way to make an estimate of the amount of gas that actually leaked out? Well, if we wanted to kind of come up with a reasonable estimate, we could take the average of the max and the min. And if we averaged 3 and 3.5, we would get 3.25 gallons. So if we had estimated 3.25, but the actual was either the 3 or the 3.5, our maximum error has now been cut in half, and it's now just 0.25 gallons. So what is the max amount that could leak out in the second minute? Well, in the second minute, that's from minute 1 to minute 2. The higher rate here is 3 gallons per minute. So if we stayed at 3 gallons per minute for the entire minute, we could have lost 3 gallons in the second minute. Or the minimum that could have leaked out is this rate of 2.6 gallons per minute. So at minimum, they drained 2.6 gallons out of the tank in the second minute. So the upper bound, or the maximum total amount of gas that could have leaked out during the entire 4-minute interval, would be the 3.5 gallons that could have leaked out in the first minute, the 3 gallons that could have leaked out in the second minute, the max of 2.6 that could leak out in the third minute, and the max of 2.3 that could have leaked out in the fourth minute. And if I add these up, I'm going to get let's see, 10.9, 3, 6, 8, 10, 10.9, 11.4 gallons is the maximum amount of gas that we could have lost, that I could have lost. Now the lower bound, we're going to go with the lower rate on each interval. So it'll be the 3 for the first minute, 2.6 for the second minute, 2.3 for the third minute, and 2.1 for the fourth minute. So my setup is 3 plus 2.6 plus 2.3 plus 2.1. And that minimum amount is going to be 3, 5, 7, 9, 10 gallons exactly. Which means that the total amount that leaked out must have been between a minimum of 10 gallons and a maximum of 11.4 gallons. So if we had guessed 10 and the real answer was 11.4, or we had guessed 11.4 and the real answer was 10, we could have been off by 1.4 gallons. But if I had taken an average between the lower bound and the upper bound, I would have gotten 10.7 gallons, and then my maximum error is only 0.7 gallons.